Hey guys, happy Star Wars Day. Got my Star Wars periodic table shirt on. Combination of science and Star Wars, so may the 4th be with you all. What we're going to do today is just finish up with the last section of our notes on simple machines. So the notes that you do on pulleys are going to be part of the activity that Mrs. Morrow posted that you're going to be working on. And then the last section of notes is just a little bit here about power and compound machines. So this concept of power is a measurement of basically how quickly work is done, how fast work is done. So it requires you to know how much work was done and how long it took to do that work. And so that's called power. The formula that we have for power, you could probably guess based on my description, is work done divided by the time it took to do that work. The unit that we use is the watt, and the watt is named after a Scottish inventor, James Watt, who in the late 18th century refined steam engines and is really important to the a machine that was important to the Industrial Revolution. So it's named after James Watt, and 1 watt of power is equivalent to 1 joule of work being done in 1 second. Okay, so if you could do a joule of work in a second, that's 1 watt worth of power. And watts, you see that unit used in different contexts. You could see it used in electricity. When you think about like a light bulb, the wattage of the light bulb is an indication of sort of how much energy it's using over time. And so a higher wattage light bulb uses more energy, it's brighter. And so watts used in that context. It's also used in talking about engines and motors. And you may have also, another unit used to express power is horsepower. So you see this image I added in the lower right corner. Horsepower is a unit that was used in the beginning of the Industrial Revolution, that people wanted a way of comparing how much work a steam engine could do compared to the work they knew that typically they would do with animals such as horses. And so 1 horsepower is equivalent to about 745 watts of power. It's the amount of power that a horse could provide. And so people, as they started to use machinery, they use that as a reference that they can sort of relate to. So if we look at how we use this equation, this formula in an example, if I had a clothes dryer in my house and it does 15,000 joules of work in 3 seconds, what's the power of that clothes dryer? Well, we write our formula. The work done divided by the time, substitute in our answers, 15,000 joules per 3 seconds, and then do our division, and we come up with our answer, 5,000 joules per second, which is equivalent to a watt, so 5,000 watts. The last topic we'll just talk about here quickly is something called compound machines. So we've been talking here in this unit about simple machines: wheel and axle, wedge, pulley, lever. Okay, these are simple machines. They're one type of machine, but they are often combined to form what we call a compound machine. Compound machine is just several simple machines sort of combined together into one device to perform some certain task. And there's lots of examples. Most machines that you probably think about that might have around your house are compound machines. They have different parts to them that allow them to work. So an example is pizza cutter here. This pizza cutter has several simple machines sort of built in. You have the wedge, which is the blade of the pizza cutter. Let me see if I have one. I'm in my kitchen right now. 1 second. Back in a minute. Hold on. Alright, got a pizza cutter. I don't know why I really needed to get this to do our notes, but pizza cutter, okay. Let's see, cutting my pizza. So you have the wedge part, which is the actual sharp blade. You also have an axle and a wheel here, okay. The wheel and axle helps multiply the force and allows you to also you have basically a lever where you use this handle and you can pivot around this fulcrum. So that is an example of a compound machine. And I don't have this style of this is a corkscrew, one type of corkscrew. I don't exactly have that type. I thought I did, but this corkscrew has this is sort of a different version of it. Okay, actually, so this is a corkscrew. What we have is, again, a compound machine. I have this blade area here that you cut the foil off of a bottle of wine with. You have this screw section, okay, that you screw into the cork. This is also actually a wheel and axle. This is the axle. The wheel is this part that I'm turning. And finally you have a lever up here where you put the this section on your wine bottle and then you lift up on it to pull the cork out. So this has several simple machines all working together to accomplish some task, and that task is to get the cork out of a bottle of wine. So you could think of lots of these simple machines probably around your house, in your backyard, and one of the things I'm going to do in our final activity of this unit is to try to find some of these simple machines around your house and tell about how they work. So that's it for today's notes. That's the end of our simple machine notes. And I hope you have a great Star Wars day today. See you later.